Hi, my name is Vikentiy Fesunov, and I will talk to you about my experience.
You're not visible, come here.
Take three. It's actually being recorded, right?
Yes.
Overlap.
There you go.
So this talk is not about performance. So
Still not visible. Okay.
JIT compiler, if you don't know, compiles code right before execution when you need it. So a while ago I found a new library called JIT. It provides an interface to the GCC compiler backend and allows you to build the functions interactively using other functions, convert them to machine code, and execute them right on spot. It has simple C API, which lends itself perfectly to embedding to Perl. So as an example, I'll make a small function that squares its argument using the GCC JIT. First we get the context, then we get an object that represents integer type out of that context. Next we create a parameter using uparam that tells you there is a function parameter somewhere of this type with that name. It's called param. And then just call a new function, passing into a type, name, and array of parameters on line 11. Really simple. And then we create a new multiplication operation, passing it the parameter twice, so it multiplies itself. Lots of bit difficult, but don't worry about them now. We just create one block for our function and return, finish it immediately with a return, which returns our product. That's it. We can compile it now. Get the pointer to our function, which is just pointer to somewhere in memory where the code starts, which we can use FFI raw to call. And that's it. But FFI stands for Foreign Function Interface, and with building code in Perl, can't we make it native? Perl has an interface to native functions for native extensions, which you write in C using a system called access, and it looks like this. So in theory, if we make our runtime code produce something that is compatible with what access does, we should be able to call it directly. Can we? In the end, what access feeds to the C compiler, it looks like this. It's very complicated. But the real part is this. All access functions follow this API. All they get is a pointer to the Perl interpreter state, which you have to handle somehow. Here what I made as a solution to this. It's a small function, small library that uses some macros to put access macros into individual C functions. So then you can call them independently from whatever you like. DXS args was one of the problematic macros because it introduces a set of local variables into each access function. I had to create a struct to hold them and use macros to fool the rest of the system to use that struct instead of local variables. And on the Perl side, Ouroboros exports pointers to these functions as numbers to Perl. These numbers then can be fed to your JIT system or something else to call them, to manipulate the Perl pointer that you get from Perl. And as a bonus, you can use now this library to write extensions in something better than C, like Rust. So, another example, we'll do this access code using GCC, JIT, and Ouroboros. It's a bit large, so don't worry if you don't really follow. So as before, we acquire context. Next, we create a bunch of types. We need lots of them now, some primitive types. We recreate the Ouroboros struct in GCC JIT so we can allocate enough space for it on stack. Then we create some function pointer types that will describe to GCC JIT how to call functions that are supported by your boards. Then we create values that GCC JIT can use to call them. So they are basically constants of specific type which is described. So it's new value from pointer, and pointer is just a number. And we use the several types we defined earlier. Next, we create our function, and per access it has to take two arguments, pointer to Perl and pointer to CV that represents the function inside. So, right, and it returns void, it returns nothing. Next, we create a new local variable with new local of stack type. It allocates the structure in the stack. Next, we take an address, and on line 59 we call a new function 56. We have call through pointer, so it instructs GCC JIT to add a call through the pointer value we had before. It calls then a stack fetch to get an SV and SV ID to get an integer value out of the SV, all through pointers. Then we multiply the values like before, and then we call a bunch more access or your board's functions to put it back on the stack the way access requires us to. And we finish our only function block with the return value, without return value, with a void return. Next, we can compile it, get the pointer, and this time we use DynaLoader to install it as a native access extension, and we can call it like it was a normal function. So it's a lot of code for a very simple example. What should you do with it? A lot of possibilities. I didn't have any ideas what to do with it. I was just playing around. I thought I can define, abstract away all this boilerplate behind a DSL, so make some Perl functions that would take blocks, and to make nice, but expressions would be problematic because expressions are parsed by Perl. It says variables, it tries to evaluate them. So I thought maybe I should create a new syntax for these expressions, but they would be strings. But wait, our program is already parsed, so maybe we can compile Perl. Not really. And I will end with a teaser preview of what I'm working right now. It's a compiler that compiles it doesn't compile Perl, although it looks like it. It takes code reference, analyzes its structure, and compiles it as if it was a different language. That should be mostly compatible with Perl, but it is allowed to be different in cases where the compilation doesn't make sense, or Perl doesn't make sense in context of compilation, because there is already an interpreter we are running inside, so no need to re-implement that. It can be just, it parasites on Perl syntax to define new programs with different semantics. And that's it. Wow. So there is a bunch of projects on GitHub, and your help will be much appreciated.
I have a question.
Yes.
Why do some of the methods have undef as the first parameter?
It's used by GCC JIT to pass source code location information in a spatial argument, but it can be null, which is null here. Any questions?
So this GCC JIT library,
Yes.
what does it exactly do? Like it generates like assembler code, or it's multi-platform, or what?
It generates machine code, the binary that is used by the processor to execute.
Yeah, I know, but the part that it wasn't clear to me is that if you have to actually type the platform code, or it's some sort of abstraction over platform code, or yeah, what?
It's so in the end it generates assembly code and then converts it into native machine code. It's a whole compiler, and it types at a stage roughly behind the parser. So when GCC parses the C code, it then uses almost the same API to build the machine code. So you can have multiple functions, you can use inlining and stuff like that. I don't know if that answers the question.
Cool.
Oh, that's it.